So when you get a chance, please take care of your summer assignments, because I'm gonna like those arithmetic skills are gonna be helpful. Oh, okay. First and foremost, I got to tell you guys this, because I always have a hard time with this. Well, trying to convince people. Calculus is not hard. I'm telling you right now, calculus is not hard. What is hard is the algebra. The concepts for calculus are straightforward. The concept, oh, I just got the chills. The concepts for calculus, guys, every kid I've ever had in calculus, they've always understood like the concept, like what's going on behind it. Like, oh, I need to figure out area under the curve. Oh, it's an instantaneous rate of change. The concept itself, if the calculus exam was all conceptual, where they didn't ask you to calculate anything, everyone would get a 5. Because the concepts for calculus is not difficult. What is difficult is the algebra behind the calculus. Does that make sense? So the algebra, the arithmetic, like sometimes, especially now during a pandemic, you might not have the algebra skills. You might be like, I know what I got to do, but I don't know how to. So it's the algebra that is stopping us. So if you feel that you need like more algebra work, come in and say, Chavez, I need help on doing this type of algebra, and then we'll talk about that algebra. And then whenever we get a chance during lab, I'll slow down and I'll be like, guys, it is the algebra that's required. All right, so hopefully when you guys get a chance, read that. I really do believe that we have a chance to get 100% qualify. I mean that. If I did not think we had a chance to get 100% qualify, I wouldn't tell you guys. We've come close 2 out of 3 years. Why not this year? Wouldn't it be cool, guys? I think it would be real cool. I really do. All right. So I guess let's read this here. Do we have a volunteer? Oh, you know what? I'll read it because you might not know how to. So on the left-hand side, it says, all right, let's start with limits. What is a limit? What does it mean to find a limit? Let's start with the notation and go from there. The notation for a limit will look like limit as x approaches c of f of x equals L. That's how you say this right here. Limit as x approaches c of the function f of x equals some number, L. And I think I put it here in the quotes. The limit of f as x approaches c is equal to L. And guys, all a limit means is as x approaches some value c, what is the function converging to, the y value? So that's all it means. So, and I think I say that. No, I don't. This right here means from the left, that little minus sign, from left. And that little plus sign means from right. And I put that in the note. This means x is approaching from the left or right, respectively. Let's practice finding limits graphically and use correct notation. So I have a graph, and this graph is this function, and then we all had a class called Algebra 2, so we should have an idea on how this graph looks. But relax, if you don't, we're going to help you. And it says here that I have a hole at -376. So here's my graph. So in Algebra 2, when you guys had Algebra 2, they asked you to graph this. Hopefully, well, maybe not, because it was during the pandemic, so maybe she didn't. And it's okay if she didn't, guys. So how would we get that function? So it says here, from your previous math background, let's see how we could have obtained the sketch above using the simple analysis. Okay, so I have this function. Who remembers how to find horizontal asymptote? Yeah. So, but why though? Did you memorize that, or you just like? Do you know the concept?
I probably do, but I don't know how to explain it.
Okay.
It's not something I can memorize.
So what you're talking about, Ms. Parker, is end behavior. So remember end behavior, guys. As x gets really, really large, we don't care about 5x minus 3. The 2x squared becomes the monster. And the way I learned it, I've used this example before, and sometimes kids get confused, sometimes they get it. So I'm going to tell you the way I learned it, and if you don't like it, that's okay. You can just throw it away. Did I tell you guys yesterday or last year about spitting in the ocean? If you spit in the ocean, does the ocean rise? No, because the spit is insignificant. Does that make sense? So when I was in high school, I learned this by my teacher telling me, what is ocean? Chavez, well, they didn't call me Chavez, they called me Omar. What is ocean? The 2x squared. And the 5x minus 3 is spit because it's insignificant only as x gets large. Does that make sense? For end behavior. So what is ocean in the bottom? The x squared. And the 9 is spit. So what's my end behavior? 2x squared over x squared. Look what cancels out. Doesn't the x squares cancel out? And this is just going to be approaching 2 as x gets large only. Does that make sense? Now check it out. Look at this graph. See how I have a horizontal asymptote right at y equals 2? And look, beautiful, as x gets large, that arrow is starting to converge on the y value too, only as x is getting larger in magnitude. Does that make sense? And now technically as x goes to the left, that is actually saying x is getting smaller. I actually don't like that, but that's fine. We're going to say the magnitude of x is getting larger in the negative direction. Are we okay, guys? As x gets larger in the negative direction, notice that I still also converge at 2. Does that make sense? Yeah. And it comes from your end behavior. Cool or not cool? There you go, guys. So you guys are beasts. We got it. So our horizontal asymptote is y equals 2. Now, let's see. How do we get that vertical asymptote? Well, let's see. VA. Do you guys remember how to factor? So in the bottom, everyone can do the bottom pretty easily. I have x squared minus 9. That's the difference of squares, right? So you can just write x plus 3, x minus 3. But in the top, what am I trying to factor out, guys? I'm trying to factor out this guy right here. There's only one way to get a 2x squared in the ax squared position. Ax squared plus bx plus c. That is 2x times x. There's only one way to get a negative 3. 1 times 3. But where does it go? Do I put the 3 here and the 1 here? Don't write that because it's I think that's the wrong one. Yep, that's wrong. Don't write that one because it's wrong. How do I know, Chavez? How do you know it's right or wrong? Well, look, guys. If I were to go like this, let's see. 2x times 1, that's 2x. And then 3 times x, that's 3x. And the difference between 2x and 3x is just 1x. But the middle is not 1x. The middle is 5x. Do you guys see that? So I need this one to be 3 and this one to be 1. Now look, 2x times 3, that's 6x. And then 1 times x, that's 1x. And the difference between 6x and 1x is 5x. Do you guys see that? So now what do I need the 5x to be? I need it to be a positive. So the bigger number needs to be plus. The smaller number needs to be minus. Do you see how we did it? So hopefully you did a lot of that stuff in Algebra 2. Now maybe we're a little rusty, and that's okay. Now look. Now that we did that, there's a factor that cancels out. What factor cancels out?
X plus 3.
Because the x plus 3 cancels out, that means I have a hole at x equals negative 3. That's a hole, H-O-L-E. Cool or not cool? All right. Now that I know that those cancel out, the only factor I have left is that x minus 3. Because it did not cancel out, this x equals 3 must be a vertical asymptote. You can't divide by 0, guys. 3 minus 3 would give you a 0 on the bottom. So notice at this green line here, that's my vertical asymptote of x equals 3. Do you guys see that? All right. Now what about my hole? Well, I have a hole at negative 3. How would I find the hole? Well, the way you find the hole, guys, is to plug in a negative 3 into whatever you have left. So if you want to find the hole, negative 3 comma, let me do this on the side. 2 times negative 3 minus 1 divided by negative 3 minus 3. 2 times negative 3 is negative 6 minus 1 is negative 7 divided by negative 6. Negative divided by negative is a positive. There's my hole at negative 376. And we did some of this in the beginning of pre-cal as well. You should have done it in Algebra 2, but because of the pandemic, maybe you didn't reach it. But that's how we got, see, and now we got everything, guys. We got the end behavior. We know that we can't cross the vertical asymptote. So that's how we got this graph here. And I probably shouldn't have used green there, but that's fine. And we'll probably practice doing graphs tomorrow or this week. We'll go as slow as we can. Are we still okay? Can we take some more? Okay, let's keep going. So here's that same graph. So today we're just going to practice with graphs because we want an easy day today. Practicing with graphs. All right. As x approaches negative infinity, so I'm looking at this. As x approaches negative infinity, the graph of f of x is approaching what number? What y value am I approaching? 2. There it is. How do you write it in limit notation like this? Write the word limit, put the number x in the bottom, put an arrow, and put negative infinity. And then write f of x. So this means limit as x approaches negative infinity of this function, and I'm approaching 2. Done. Does that make sense, guys? All right, let's go to the next one. Limit as x approaches infinity. Well, again, if I approach infinity, what y value is this graph looks like it's converging at? 2 again. You write limit as x approaches positive infinity. You can put the plus symbol in the front if you want, but it's understood if you just write it like that. And that also equals 2. This third one here. As x approaches negative 3 from the left, the graph of f of x is approaching. So if I approach negative 3 from the left, so here it is. I'm approaching, it's this one in black, guys. Do I have black? I don't. Yeah, here it is. This one in black. If I approach negative 3 from the left, I'm approaching what y value? What y value is that? 7, 6. What just happened? What just happened? I'm approaching negative 3 from the left, guys. I don't have to be continuous. It's obviously that I'm not continuous, but I'm converging. I'm approaching a y value. What y value am I approaching? Well, that y value. Negative 3, comma, 7, 6. You're approaching that 7, 6. What's up? That I'm to the left of the hole. Like, that I'm, okay, what does it mean coming from the left? What happens is I get closer and closer to 3, to negative 3. So a negative 3.1, a negative 3.01, negative 3.001, negative 3.0001, negative 3.00001. As I approach from the left-hand side, my y value is getting closer and closer to what? Yeah, don't worry. We're going to do a whole bunch of this. Did I answer kind of your question? Okay. So that's what it means, guys. We're just approaching from the left-hand side. I'm approaching a y value. What is that y value? So maybe I should have done a better graph than a graph of 7, 6. I should have done one that approached a whole number. So my bad, guys. Next year I'll fix it. I'll fix it tomorrow. I'll do a new graph. How does this graph look? How does the limit notation look? Limit as x approaches negative 3. Now I'm approaching from the left. So on the upper right-hand corner, you put a minus sign. Of f of x equals 7, 6.
So you have both the negative on the 3 and then a sign.
Well, the negative on front of the 3 is because I'm approaching negative 3. But the negative on the top right-hand corner means left. Do you know what I mean? Okay, so look at this one. As x approaches negative 3 from the right, the graph of f of x is approaching, well, if I approach from the right, so negative 2.9, negative 2.99, negative 2.99999, I'm approaching that same y value, which is 7, 6. So how does this limit look? Limit as x approaches negative 3. And on the top right-hand corner, I put a plus. That means from the right of f of x equals 7, 6. Yes, ma'am?
So because it's a holder, you have to kind of stop?
Well, because there's a hole, the function's not defined at negative 3. So if I were to tell you what's f of negative 3, this would be undefined. But it does have a limit. The word limit just means, what am I approaching? That's all it means. Do you know what I mean? That's all it means. What am I approaching? Now, it doesn't always approach something, but in this case, if you're approaching from a direction, it will approach something. But, yeah, in this case, both directions I'm approaching.
It's kind of like an obstacle.
It's kind of like a what? an obstacle.
You're saying, of course, it's approaching it.
I don't know what you mean by obstacle, but yeah, I think you have an idea. Like all it is what y value am I converging to?
Okay, yeah.
Yeah? Okay. All right. So look at this. As x approaches -3. So here's what I was trying to say. Because if I approach -3 from the left and from the right, do I approach the same y value? Because I approach the same y value, this limit does exist. Do you guys know who Lindsay Lohan is? I mean, I don't know, guys. You guys are like Lindsay Lohan is. There was a movie, I think it was called Mean Girls, and in the movie, Lindsay Lohan goes, "The limit does not exist." Do you guys remember that? And that is because when you approach from one side and you approach from the other, they didn't agree. And it was a simple one. She made it sound like it was. Go back and look at it and you'll see that it's a basic one. If you don't approach, so this limit does work because if I approach from both directions, I'm approaching the same y value. Because I'm approaching the same y value, this limit exists. That limit is that y value. Cool? So, here we go. Limit as x approaches -3, and you don't have to put a plus or minus, of this function is equal to 7, 6. Cool or not cool? If I had like a jump discontinuity, I'm approaching a specific number here and a different number. Yeah. All right, here we go. The next one, guys. As x approaches 3 from the left, the graph of f of x is approaching. Well, if I approach 3 from the left, I'm approaching, what is this? Negative what? You can also say does not exist, but I want the behavior. Negative infinity, guys. The y value is going down forever, no? As x approaches 3 from the left, so here I am from the left, I'm approaching down forever. You can never touch the x equals 3 value. That makes sense, guys? Don't worry, I know, we're just getting used to it. Limit as x approaches 3 from the left of this function. This has actually, you can write two solutions. You can either say infinity or does not exist. Because infinity is a behavior. If it's not a number, you would write does not exist because you're not converging at anything. Both are correct. What's up? Negative. Yeah, you're right. Negative infinity. Negative infinity, sorry. Sorry, YouTube, if you're watching. Are we still okay, guys? What's up? Ask. Negative infinity is a behavior. So because it's a behavior, you can write does not exist. The better answer, in my opinion, is this one, but both answers are good. When you're taking an exam, if it's multiple choice, I will either have one or the other. I will not put both. Same with College Board. They would not put both. Cool? All right. As x approaches 3 from the right. As x approaches 3 from the right, I'm approaching positive infinity. So this limit as x approaches 3 from the right of this function, you either write positive infinity or DNE. 3.1. So when we're approaching from the right, think of numbers to the right of 3. 3.1, 3.01, 3.001, 3.001. As I get closer and closer to the x equals 3 value, the y values keep going larger. What's up? Well, we're looking at like what I'm approaching. So when I say limit as x approaches 3 from the right, you look at the x value and you're like, okay, I'm approaching from the right. 3.1, what's the y value? I don't know, 3.1, the y value is something like 100. Let's just make that up. At 3.01, the y value is like 200 or 500. At 3.001, the y value is an even bigger number. As you get really, really close to 3, here's 3, it's just going to be getting bigger and bigger because you're never going to touch it.
Right,
because it's a vertical asymptote. You know what I mean? All right, let's see. Limit as x approaches 3, the graph of f of x. Does not exist. I have two different behaviors. One behavior from the right is going up. The other behavior from the left is going down, negative infinity. Because my behaviors do not match, you're just going to say does not exist. The limit, what? The limit does not exist. And that's it. And you come to your first proof right here.
So if they're the same kind of line.
Then you could use the behavior. Yeah, if it were to go both up, then you could say positive infinity on both.
Does not exist the same thing as undefined?
No.
Okay.
Undefined is specifically for like a function. Yeah. All right, here we go, guys. Your first little rule here. And look, it's simple, guys. A function f of x has a limit as x approaches c if and only if the right hand and left hand limits at x equals c exist and are equal. In symbols, left equals right. So you can just say that. See, the left side equals the right side, which you can just drop the minus and plus because they both equal that same number, and it equals that same number there. That whatever that number is, that limit. And don't worry, we're gonna test it right now, guys. That's like what we just did. Limit of x approaches negative 3 from the left, negative 3 from the right, and it was approaching that 7, 6. That makes sense, guys? So don't worry, look, we got an easy, I probably should have started with the easier ones. So now I'm regretting starting with that. Maybe I should have started with this one. So example 1, I should have started with this one here. Look at this, we're just using that graph. You guys ready? It says, I'm approaching negative 1 from the what direction? The right. So here it is, here's negative 1. If I approach from the right, what is this y value? So that's a 1. That's it. Letter B. Letter B says I'm approaching the number 1 from what direction? Left. So look at the number 1 and approach it from the left. If I approach from the left, what y value am I approaching? 2. Perfect. That's it. Look at letter C. I'm approaching 1 from what direction? The right. So if I approach 1 from the right, what y value am I approaching? 1. Is this making sense, guys? Yes, I'm approaching, x is approaching 1 from the right. So if I approach 1 from the right, the y value that I'm approaching is 1. Does that make sense, guys? What's up, Parker?
When you say from the right, are you going this way?
Yeah, so here's 1, and I'm approaching from the right. So I'm approaching that way, see?
Oh, okay.
Cool? Okay. Look at letter D. It just says 1. So in order for this limit to exist, the left and right must match. Does my left and right limit as x approaches 1 match? So this one you're going to say what? Does not exist. There it is. It's that simple, guys. The limit from the left is 2. The limit from the right is 1. I do not approach the same y value, so it does not exist. Are we still okay, guys? All right, letter E. Limit as x approaches 2. What do you guys think? 1. Just 1. If it says limit, you're just looking at what you're approaching. You don't care. You don't care that you're discontinuous. You just want to know about what you're approaching.
And if it doesn't have a plus or a minus in the top.
Both sides must agree from the left and the right.
But if there was one I was going up and
It would not exist, right? Because they would be approaching 2 different y values.
And the points on it does not matter.
Well, it does.
Well, yeah,
But for the word limit, no. Yeah, it does for letter G when we get there.
But you have to have a continuous line for it to be.
oh, it has to be
Like the line, you have to have, I guess a function, or you have to have some
For the anytime we're dealing with limits, we don't care whether it's continuous or discontinuous. We just care about what are we converging as x approaches that value. Now, if we're looking at directions, if I approach a specific x value and I'm approaching 2 different y values respectively, like if I approach 2 from the left and it's like, look at this one. If I approach 1 from the left, the y value is 2. If I approach 1 from the right, the y value is 1. Does the limit exist as x approaches 1? No, because they don't match. It doesn't do this. It doesn't do this part.
But you can't have a limit on a point, or can a single point have a limit, or can it, or do
Yeah.
you have to have?
No, it does. For limits, the continuity doesn't matter. It can be discontinuous.
So for 2.
Okay, repeat the question.
So could there be a limit on the point 2, 2?
No, because there's nothing that's gonna. There's no behavior.
It has to have some behavior, like it has to be going.
Yeah, it needs to be a curve. That's just a singularity. Just a point.
So that means like for letter A, it says like x approaches from the right, but you can't say that same one like from the left.
Because there's nothing to the
No
left.
limit exists.
For this one, there would not tell you limit x approaches -1 like that because there is nothing from the left. Like nothing exists on the left. So on this one, they have to tell you.
So they just wouldn't write the question.
Yeah, they would not. They would not write. What's the limit of x approaches -1? Like period, because it doesn't exist. Like there's nothing to the left. You know what I mean? Like there has to be behavior to the left and right for. Cool. Okay. What's up? What's up?
Can you go over B and C?
Yes. Letter B. This says as x approaches 1 from the left. So if I approach 1 from the left, here's number 1. If I approach 1 from the left, the y value is 2. So you're approaching from the left. Look at letter C. This one says from the right. So if I approach 1, so here's number 1, from the right, so what's that y value? 1.
Whatever value is first from that direction.
From that direction, yes. Look at letter F, guys. There is no right side. There is no right side, so there's only one direction to approach. Do you see that, Taylor? There's only one direction to approach for 3. There is no right side. So if I approach 3 from the left side, what y value am I approaching? That's it. That's it.
So they could not ask you to what the limit.
As x approaches 3, I mean, they would never ask what's the limit of x approaches 3 from the right side. That's for sure. You see that, it's a typo. It's possible that someone without thinking, some author without thinking is going to write limit of x approaches 3. He means from the left side because that's the only side that there is. Look at letter G. Everyone look at letter G. Don't write anything down. Just listen. Do you see the word limit in it? So this just means when this function, which is, I guess they're calling it G, when the x value is, when the f value is 2, what is the y value? 2. It doesn't say the word limit. All it means is, well, this is my function. This is my function f, and hopefully you did this a lot in Algebra 1 and Algebra 2. When x is 2, what is the y value? When x is 2, the y value is 2, because that's where you're defined. You're not defined over here. That's a whole. It's like a piecewise function maybe sometimes. Does that make sense, guys? And we'll do a whole bunch in a little bit so you can see. We're going to do a whole bunch. Look, we got another one. Some more. We got time? Oh, yeah, we got plenty of time. We got 20 minutes, guys. You guys ready? All right, so check it out. Here we go. This graph, they're calling it f. So it's a piecewise function. So maybe we should have started with piecewise functions. The first one, limit as x approaches 3 from what direction? The left. So look, I'm going to look at 3 from the left, negative 3. Oh, sorry, 3. I'm going to look at 3 from the left. What is that y value? 1. See how I did it, Parker?
Yes.
Now look at the next one. It says limit as x approaches what? 3 from the right. What's that y value? There it is. Does the limit as x approaches 3 exist? Why not? They do not equal each other. The left does not equal the right. Did that make sense, guys?
Yes.
Perfect. Now look, now I say what's f of 3? Ooh, do I even have anything in that one? Then, yeah, you have holes everywhere. So you're going to say undefined. The word undefined is specifically for evaluating functions and does not exist specifically for evaluating limits. Cool? So, okay, let's go to the next one. This one wants to know, it says, use the graph of the function f of x shown below in order to determine all values of a for which the function as x approaches a is equal to 0. Okay, so first I want to know where this limit approaches 0. So let's look at the graph. Let's read it left to right. Left to right, I see my first x value at, do you guys see it? -5. That's one answer. If you approach, now look, let me write it here, guys, so you guys can see. Limit as x approaches -5 from the left is 0. Limit as x approaches -5 from the right is also 0. I guess you could have just written limit as x approaches -5. Do you guys see that? Perfect. We keep going, and I see another one. Where's the other one? 2. Can I just write limit as x approaches 2 of f of x equals 0? Yes, because if you approach from the left and the right, it's the same, guys. And shown below in order to determine all values. Okay, I see a specific one. I don't know. Obviously, I took this from Delta. I don't know if they're specific enough, like from one direction, but I'm going to go ahead and write that one direction here. I see another one. Limit as x approaches 7, but only from what side? What side, guys? It's the left. So I'm going to put a little minus sign. Equals 0. And there's one more.
For 2, how we did it from like that it was approaching from both sides, right? We did that because it's approaching from both sides.
Correct. Mhm. There's one more, guys. Which one? Yep. If I had to take a guess, the way this question reads, because I took this one from Delta, I should have written in here, took it from Delta for good. I just read that whole cite your sources, right? So next, look, I'm saying it. Look, there it is. Took it from Delta. The way this reads, because I don't see an arrow sign on the top, they probably just want x equals -5, x equals 2, and x equals 8. But when you guys get to Delta, you guys tell me which ones they want. Cool?
Yeah, what was this with the x? Why did you put -5 from left to the right?
Oh, I just wanted to show you guys. I just wanted to show you guys. Limit as x approaches -5 of f of x equals 0. There, this one. Yes.
We don't do anything with that point on -7 because there's no confusion.
Yeah, because it's not coming from the right. So, but if they told me like directional ones, maybe put it in there. But the way it reads, see how this a doesn't have a plus or a minus in the top right? The way it reads, I read it like they just want to know that they agree from both sides.
Okay, so you wouldn't put the 7.
No. I just did that for you guys.
I'm sorry, you would understand because what?
Because the way it reads, it says determine all values of a, and see how the a does not have a plus or a minus in the upper right hand corner? It doesn't have a plus or minus. So because it doesn't have a plus or minus on the upper right hand corner, I think they just wanted to be from both sides. You know what I mean?
So
If it had a, I think they, I don't remember. On Delta, if you see a textbook, if you see a textbook problem and it have a little, like, or if it says the word for directional or bidirectional, then start doing directions. But this one, it looks like it's just, it's a concept that you gotta worry about. You don't have to worry. Are we okay so far, guys? All right. Look at this one. I think this is the last one. Oh, we got 2 more. You guys think you guys can do this without doing a graph? All right, so I think we need practice on how to sketch graphs. Notice that all these x values are positive, so I'm going to exaggerate quadrant 1, and I'm going to exaggerate quadrant 1 and quadrant 4. So there it is, quadrant 1 and quadrant 4. At 0, these are all linear lines, so I should only have linear lines in here. Are we okay with that, guys? Chavez, what are you talking about? They're all linear lines. So between 0 and 1, I behave like -x plus 1. So at 0, y-intercept of 1, I'm going to say 1's right here. Put a hole. And at 1, I should be on the x-axis. So I'm going to say 1's here. A point, sorry. I said hole and I put point. Put a point. Put a point at 0, 1. and then at 1, put a hole. Put a hole at 1, 0. Does everyone know how I got 1, 0? Yeah, in case you don't know, I plugged in a 1 in here, and look, negative 1 plus 1 is 0. Or you can say the slope is negative 1, go down 1. Connect those two.
Wait, yeah, how do you know it's full?
I do not have an equal sign where x is between 0 and 1, and I don't have an equal sign. Are we okay, guys? Okay. No, ask. Are we, Taylor?
Yeah,
Okay.
yeah.
Now check it out. It's going to be 1, so I'm going to have a horizontal line between 1 and 2. But I have a solid at x equals 1, and I have a hole at x equals 2. Do you guys see that? So I'm going to go to 1, and we said that was 1, right? So 1, 1, solid, and I'm going to go all the way to 2, horizontal line, open circle. All right, what's up?
I'm just confused, like how you're like getting. So it's the one. Like, I'm sorry, I just don't know where to put the points.
Oh, okay. So pretend this is like a linear line, like y equals negative x plus 1. So how would that line look? I would have a y-intercept of 1 and a slope of negative 1. So down 1, right 1. See? And because you see these x values, I'm supposed to stop at 1, but there's no equal sign on the bottom. So at 1, you put a hole. That makes sense? Yeah, no, stop me. Stop me if. So, yeah, perfect. So what is this? This is just a what? That's just a point. Because it just says at x equals 2, the y value is 2. So 2, point way up here. Don't go to sleep, miss. No, you're good. I hope I woke you up a little bit. All right. Now look, Chavez, how do I do this one? I can't figure this one out. Yes, you can. Plug in a 2 in there. What's 2 minus 1? 1. So I'm at 1 again. So I'm here. And it's a hole. It's a hole. And then plug in the 3. What's 3 minus 1? 2. So at 3, the y value is 2, and that's a point. And then connect those. See? Yes. All right. Look, guys. So this is telling me I look like x minus 1 between 2 and 3. So if you want to figure out where you're at, we know it's a linear line. Plug in a 2 in here. What's 2 minus 1?
Where did you get the 2 from?
The 2 from right here. It tells me that x is between 2 and 3. So 2 minus 1? 1. So go to 2, 1. Put an open circle. And then it tells me I go all the way to 3, and I know it's a linear line. So what's 3 minus 1? 2. So go to 3, 2, and that's a solid. And then connect.
Wait, why is it a solid?
Oh, because there's an equal sign right there. I think we're supposed to leave at 11:30, right?
2 holes at the point 2, 1.
Well, technically it's just a
Or just
hole.
1, but
Yeah.
like it's
Yeah. Let's see if you guys can do this last one here, guys. Negative x plus 5. Plug in a 3 in there. Negative 3 plus 5 is 2. So I'm there at the solid. It's already solid. I know it's a hole, but it's already solid from the last one. And then plug in a 4. Negative 4 plus 5.
So if it's solid from the last one, but
Leave it.
It says there's a hole, it's still.
Yeah, leave it, right? So negative 4 plus 5 is 1. Open or closed? Closed. There it is. There's how my piecewise function looks like. So it looks like we're going to need help with piecewise. So we're going to have to do that. So let's see if we can answer these questions really quick. You guys ready? Limit as x approaches 0 from the right. 1. I'm going left to right, guys. I'm going left to right on the bottom. Yeah. Limit as x approaches 0 from the right. Limit as x approaches 1 from the left. 0. Limit as x approaches 1 from the left. I'm not approaching 1 from the left. I'm approaching that x-axis. Limit as x approaches 1 from the right. 1. Perfect. Limit as x approaches 1. Does not exist. They don't agree. Needs to match. Perfect. Limit as x approaches 2 from the left. 1. Limit as x approaches 2 from the right. 1.
Teachers, before we start this listening to lunch,
Lunch.
please
Oh,
make sure that you know your
yeah, we still got a little.
I know it's been a while.
11:30, right?
Please make
I don't know.
Oh, I got it right. I got it right here. Let me see what it says.
ID number.
So just in third period, 11:25. We're good. We're good. We got 3 minutes.
Those of you who have asked, you have the byways available.
Or you guys don't like this? This is fun, right? All right. Okay, that's for little kids. Let's keep going. Because they're talking about 6th grade stuff. Limit as x approaches 2. 1, because they match. Does that make sense, guys? Limit as x approaches 3 from the left. 2. Limit as x approaches 3 from the right. 2. Limit as x approaches 3. Perfect. Limit as x approaches 4 from the left. 1. Okay, the last one. Does that say the word limit? That says f of 2. What's that? 2. See if you guys, let's go ahead and wrap it up. See if you guys can do this one, and then we'll start here tomorrow. If you're ambitious, there's a Delta assignment. You don't have to do it. I'm gonna fix the date. I'm gonna fix it for it to be due tomorrow. If you're ambitious, you can try it out today. If not, no big deal. All right, guys, good job. Are you guys happy with today's first day?
Does it have to be a small binder, or can I just put in a big binder with like my other?
Yeah.